Hello, grade 12s. This is video number 7. That is the conclusion of momentum and impulse. We said the momentum is the product of mass and velocity. That is P is equal to mv. Then we said the momentum is a vector quantity, which means there is a magnitude and a direction. The SI units for the momentum is kg. Then we have what? Meters per second for speed. Therefore, for momentum will be kg meters per second. These are the SI units for the momentum, right? Then we also talked about the change in momentum. Since we know that when the object is changing speed, therefore the object has the change in what? In momentum. Okay, there is a change in momentum. So we have a change in momentum. That is, the change in momentum is always the momentum final minus the momentum initial. Remember that the momentum is mv. So to get the final momentum, you will use the final velocity. To get the initial momentum, you will use the initial velocity. Then we have Newton's second law in terms of momentum, which states that the net force acting on an object is equal to the rate of change in momentum. So F net is equal to change in momentum over change in time. Now, there are applications of impulse. Okay, we'll get to that. Then we also talked about the impulse, that is F net times delta t. That is the impulse. Is defined as the product. Impulse is defined as the product of the net force and the time, which is also equal to the change in momentum. That is an impulse. Then there are applications, safety precautions, if I may. So we have the let me make an example of a cricket player. A cricket player will move his hand backwards when it catches the ball. Why he is doing that? He is increasing the contact time, right? When you are increasing the contact time, then the net force decreases at constant change in momentum. Constant change in momentum. Okay, so the seat belt will increase the contact time. So when the contact time increases, or the collision time increases, then the net force decreases, then the injuries decreases, right? So that is how to explain why we wear seatbelt, why the cricket player moves hands backward before catching the ball. He is increasing the contact time. When you increase the contact time, then the net force decreases, and while the change in momentum is constant, right? All right, so we also talked about the conservation of linear momentum. The conservation of linear momentum says in an isolated system, the total linear momentum is conserved. Sum of momentum initial is equal to the sum of momentum final. So sum can be written in this way. It's 1 plus momentum of object 2 plus momentum of object 3, and so on, which is equal to momentum final. This is initial, this is initial, this is initial. Final of object 1 plus momentum final of object 2 plus momentum final of object 3, and so on. Then we also talked about the elastic collision and inelastic collision. We said for elastic collision, the sum of EK initial is equal to the sum of EK final. The sum of EK is EK initial of object 1 plus EK initial of object 2 plus 3, and so on and so on, which is equal to EK sum of EK. So it's supposed to be, or not sum, it's just EK, there is no sum here. EK initial or final now, EK final for object 1 plus EK final for object 2, right? So that is elastic collision. For any elastic collision, the sum of EK initial is not equal to the sum of the collision final. Let's go to one question from previous question paper. Okay, this is the question number 5. The diagram shows two trolleys P and Q held together by means of compressed spring. So the spring is compressed. Once you release them, the spring, then the trolleys will move apart. Frictionless horizontal track. The mass of P and Q are 400 grams and 600 grams respectively. So we need to change the mass because it is in grams. Remember we said it must always be in kilograms. When the trolleys are released, it takes 0.3 seconds. The time is perfect, that is in second, for the spring to unwind to its natural length. The trolley Q then moves to the right at 4 meters per second. So we have P, that is mass of P, which is 400 grams. Then we divide by 1000. Then we get 0.4 kgs. We have the mass of Q, which is 600 grams. Then we divide by 1000. Then we get 0.6 kgs. Okay. Then we have the initial velocity of both. They were held, which means they were not moving. So the initial velocity here is 0 meters per second. The initial velocity of Q was also 0 meters per second. Then we also have the velocity of Q, which is 4. That is the final velocity of Q, that is 4 meters per second to the right, which means we take right as positive, therefore left will be negative. Take right as positive. Let's take right as positive, which means left will be negative in whatever we calculate. All right, let's go straight to the question. The first question says state the principle of conservation of linear momentum in words. That is 2 marks. The principle of conservation of linear momentum states that in an isolated system, the total linear momentum is conserved. Then 5.2, calculate the velocity of P after the trolleys are released. That is, we are looking for the final velocity of P. We are looking for the final velocity of P. Now we are going to use the conservation of linear momentum, which says, that is 5.2.1, sum of the momentum initial is equal to sum of the momentum final. Now if you can look here, these objects were not moving initially, which means this one has zero velocity, therefore zero momentum. And also this one has zero velocity, therefore zero momentum, meaning that initially we have zero momentum. Then for final, we have momentum final for P plus momentum final for Q. So 0 is mvf of P plus mvf of Q. Then we substitute the mass of P is 0,4. So we have 0,4, that is the mass of P, times the speed of P is what we are looking for, the final velocity of P, not Q, plus the mass of Q is 0,6, 0,6 times the velocity of P, Q final is 4 to the right. We said the right must be positive, so it's positive 4. Now we are going to press calculator here. So we get 2,4 here, then we transpose 2,4. We have minus 2,4, which is equal to 0,4 VF. Then we divide by this 0,4 because we're looking for final velocity, not 0,4 final velocity. So let's divide by 0,4 to get rid of that 0,4. Therefore, the final velocity is equal to minus, divide by 0,4. It's minus 6 meters per second. Remember we said take right as positive, which means this minus 6 is left. Final velocity of Q is 6 meters per second to the left. Then 5.2.1 is answered. Let's go to another question. So they say calculate the magnitude of the average force exerted by the spring on trolley Q, which means the focus is on Q, on trolley Q. Okay, so we are going to use the information of Q to get the answer. Okay, now that the question says calculate the force, that is 5.2.2. the only formula that we have for force is F net times delta T, which is equal to the change in momentum. So we are looking for a force. We have the time, which is 0,3, then change in momentum. We are going to calculate the change in momentum. F net times delta T is equal to the change in momentum. Remember, it's mvf minus mvi from the formula sheet, which is the same as P final minus P initial because of change. There is a difference between sum and change. Change, there is a minus between final and initial. Then sum, you just add. You add 1, 2, 3. Okay, so there is a difference between the two. Now let's substitute. So the time is 0,3. This is the time, 0,3. We have 0,3, so it's F net times 0,3. So this is the final velocity of q. We said take right as positive, so this one it will be negative, as you can see. So we have mass of q, which is 0.6 times the velocity, which is minus 6, minus the mass of, we're talking about q here, 0.6 times the initial velocity of q. They were held, which means the velocity initial is 0. Now we can divide by 3 both sides. 0.3, I mean both sides, to get rid of that 0.3. So we are left with here F net, which is equal to, now let's press calculator here. So we have minus 12 newtons, which means this is the same as, so this one is the force that is exerted on the spring by what? By Q, because it's in this direction. Let's go back to the diagram. So a spring will apply a force in this direction, then 600 grams will apply a force on the string, Newton's third law. So the one that is negative is the force exerted by Q on the what? On the spring. But we are looking for the force exerted by the what? By the spring on Q, which means we are going to leave a positive answer there. So the answer is 12 newtons to Q, to trolley Q, right? Let's go to another question. So the following question says, is the collision elastic or inelastic? I will only write yes or no. Okay. Now, there is no need to calculate here, because if the collision is elastic, the sum of kinetic energy initial must be equal to the sum of kinetic energy final. But in this case, the trolleys were held having a 0 velocities, which means the sum of kinetic energy initial was equal to 0 joules. Then after releasing them, they move apart. The other one move with the speed which is 4. The other one move with the speed calculated up here, right? Meaning that the kinetic energy of the trolleys changed. Okay? The kinetic energy changed. It's no longer 0 joules. Therefore, the collision is inelastic. So the answer here is no. The answer is no, because the sum of kinetic energy initial is not equal to the sum of kinetic energy final. Initially it was 0, then after collision they are moving, which means the kinetic energy is not 0. They gained the energy. Now they are moving, right? So we are done here. That is linear momentum. That is momentum and impulse. That was the last video. Please comment, like, and share. Make sure you comment so that the next video will be better than this one. Thank you very much.